Hello viewers, today we're solving mathematics. So that is under polynomial functions, which is just the remainder and the factor theorem. So we have our first equation, which is saying use the remainder theorem to find the remainder when this our first function is z divided by x plus 2, and also the remainder when this other function that we have is divided by x plus 1. So we start with our part 1. So the function that we have is 3x to the power 3 minus 2x squared, then plus x minus what, 5. So this is divided by, that is x plus 2. So what we're going to do first is we'll let this our function to be f of x. So we'll let it to be f of x, meaning that f of x should be 3x to the power 3 minus what, 2x, then squared, plus what, x minus 5. So now our divisor is x plus 2. So what we do is we get this x plus 2, which is our divisor, then we set it to 0. Okay, after that now we solve for x. What is x? X will be negative 2. So what you do now, after setting this x plus 1 to 2, get the same value of x and substitute into this our function where there is x. Whatever you get as the output, that one becomes the remainder. So f of what, negative 2, will be equal to 3. Open, this is negative 2 to the power 3 minus 2. Open, this is negative 2 to the power 2, then plus, this is negative 2 minus what, 5. So now this will be 3. Open, the negative 2 to the power 3, this will be negative 8. The negative 2, open, the negative 2 to the power 4, this will give us positive 4. Then positive times negative 2, this becomes negative 2, then minus 5. So this will be 3 times negative 8, this will be negative 24. Then negative 2 times 4, this becomes negative 8. Then negative 2 minus 5, this becomes negative 7. So we have negative 24 minus 8, so we're just adding here. So 24 plus 8, this will give us 22. Then 22, to give us 32. 32 plus 7, it will give us 39. So the answer becomes negative 39. So that one becomes the remainder. So you say the remainder is negative 39. Then part 2, we'll let what we have is 5x to the power 4 minus 3x to the power 3 minus 2x to the power 2, then plus what, x minus 1. So this is divided by, that is x plus 1. So same thing, we'll let f of x to be our function, that is 5, then x to the power 4 minus, this is 3, then x to the power 3 minus 2x to the power 2 plus x minus 1 there. So the divisor is x plus 1. So we set it to 0, then we have x, which is equal to negative 1. So where there is x, we substitute with negative 1. So f of negative 1 will be equal to 5. Where there is x, we put negative 1, then to the power 4 minus 3, open, this is negative 1, to the power 3 minus 2, open, negative 1, the power 2 plus, open, negative 1 minus 1. So we have f of negative 1, which is 5. Then we multiply this by 5 times negative 1 to the power 4. The answer becomes positive 1 there. Since the power is an even number, so we have a positive there. Then negative 3 times what? Negative 1 to the power 3, which is not an even number, the power, so we get a negative 1. Minus 2, open, negative 1 to the power 2. So negative 1 to the power 2 is positive 1 there. Then here positive times negative, negative, then here minus there. So now we have f of negative 1. This will be 5 times 1, we have a 5. Then negative 3 times negative 1, we have positive what? 3. Then negative 2 times 1, we have negative 2. Then negative 1 minus 1, this is negative 2. So now this will be 5 plus 8, 5 plus 3, that's 8. Then negative 2 minus 2, this is negative 4. So we have positive what? 4. So the remainder is positive 4. Then we have our second question, which says use the factor theorem to determine whether x plus 1 is a factor of that our function. So for x plus 1 to be a factor of a function, that means when you substitute with the divisor where there is x, the remainder should be 0. So once the remainder is 0, then we conclude to say our divisor is a factor of the function that we are given. So that's how we are going to handle this question. So what we have is 2x to the power 4 minus what? 9x to the power 3 minus what? 6x minus 1. So the divisor is x plus 1. So we're going to set it to 0. So we have the value of x, which is negative 1. Okay, so now we get this value of x, which is negative 1, and substitute it to this our function. While there is x, we substitute with a negative 1. So you have 2 open, this is negative 1, then the power is 4 minus 9, this is negative 1, the power is 3 minus 6 open, the power is x, you put 1 negative, then minus 1. So we have 2 open, the negative 1 to the power 4, that's positive 1. Then minus 9 open, the negative 1 to the power 3 is negative 1. Then negative 6 times negative 1, this becomes positive 6, then minus 1. So 2 times 1, 2. Then negative 9 times negative 1, this becomes positive 9. Then 6 minus 1, that becomes a 5. So 2 plus 9, we have 11 plus 5, that's what? 16. So we can see that the remainder that we are getting here, we are getting a 16. So this will tell us to say, since we are not getting a 0, so you say therefore now x plus 1 is not a factor. Okay, it is not a factor of our function, which is 2x to the power 4 minus 9x to the power 3 minus 6x minus 1. So that's the conclusion. Then we have our part 2. So what we have is x to the power 4 minus 2x to the power 3 minus 4x squared, then plus that is 5x minus what? 6. Then the divisor is x minus 3. So we set this to 0. So we have x, which is equal to positive 3. So now there is x, we substitute with a 3. So I have 3, that is to the power 4 minus 2 open, this is 3 to the power 3 minus 4 open, this is 3 to the power 2 plus that is 5 open, then this is 3 minus 6. So 3 to the power 4 is 3 times 3 times 3 times 3, which will give us 81. Then minus, that is 2 open, then 3 to the power 3, that's a 27. Then minus 4 open, 3 to the power 2, that's 9. Then 5 times 3 here, it is 15, so minus 6. So 81 minus, then 2 times 27, that's 54. Then 4 times 9, 4 times 9, that's 36. Then 15 minus 6, that's 9. So we'll say 81 minus 54. So get a 1 from 8, you remain with a 7. So 11 minus 4, what we have is 7. Okay, so we have a 7, then here 2. So we have 27. Then Negative 36 plus 9, so it's the same as 36 minus 9. So get a 1 from here. So 16 minus 9, that's a 16 minus 9. It will give us, let's see. So 16 minus 9. So that's a 7. Okay. They need 2. So here we have negative 27. So 27 minus 27 to be 0. So you see the remainder that we're getting is a 0. So whenever the remainder is 0, then you just conclude to say therefore x minus 3 is a factor. Okay, it is a factor of our function. That's the answer.